Thank you for inviting me, and welcome everybody. So this is a little bit, perhaps a little different presentation than you usually have. It's actually composed of two components. I will first talk about an application of remote sensing to public health. I will talk about how nighttime lights and the distribution, basically the urbanizations, how aspect of urbanization is affecting our sleep behavior. And then I will switch to another short presentation where I will talk about some practical tips for effective scientific writing in earth science. And then after that, I will take any questions that you have for any of the two talks. So as Yellow probably presented, I'm owner of my company, CropSnap. I do a few different things, but I have a background in earth science. And I'm an earth scientist at heart. I worked in medicine for a few years. I was completely into sleep. So that's what I will share with you tonight. And I also am a professor at Foothill College. So let me start a little bit. So we usually, I will give a quick and my outline, so just that you don't are lost. I will first talk about the role of sleep and the role of light in regulating sleep. I will then go over mapping light pollution from satellite data and introduce to you a largest database of sleep and sleep epidemiology for the American general population. This is really a unique database that we used for this study. And then I will show you what we found out in terms of the relation between the sleep disorder and outdoor light pollution. So this was work that was done at the Stanford School of Medicine. And it really attracted me because we always talk about using data, satellite data, to understand environmental change. And we forget that humans are also part of this change, and they're also not only actors, they're also victims sometimes, inadvertently. And as we learn more about how we are learning change, we can also learn how to react and minimize and adapt to the changes so that our health gets protected. So light is probably one of the major factors that impacts sleep. It is a big important factor because, first of all, it alerts us. If we expose ourselves to too much light, especially in the evening, we are having trouble falling asleep. And then it also affects our internal clock. And so it affects our ability to go to sleep at a specific time. And of course, you're all familiar with jet lag if you traveled anywhere. And so you know that having our internal clock disrupted has some major effects. If we have it for a very short time, we can usually get over it quickly. But if it happens for a prolonged amount of time, then there are all kinds of disorders that can basically impact our health. So in terms of pathways to sleep regulation, so we perceive the light through our eyes, the retina, and we have three different types of receptors in our eyes. So we have cones, different types of cones, which are responsible for the images in our brain, the color images that we see during daytime, and the cones have maximum sensitivity in the violet at 420 nanometers, at 530, and at 560 nanometers. Then the second set of cells are called the rods, and these are responsible, help us see at twilight, in the evening, when it kind of gets dark. When it gets dark, we don't distinguish colors. We have kind of a black and white vision, but we're still able to see. And then we have a third type of cells here with the IPRGC, stands for the intrinsically photosensitive retinal ganglion cells. So these cells don't contribute to any image forming, but they have a peak sensitivity in the blue radiation at 480 nanometers and are responsible for sensing changes in brightness and luminosity. So when the retina senses a decrease in light, that generally happens in natural conditions towards the evening, then the neuron that is part of the central nervous system transmits a message to a part of our internal clock. It's called the suprachiasmatic nucleus. And then here, basically, it signals to the pineal gland to start producing a hormone called melatonin. And this hormone is also called the hormone of darkness because it requires darkness to be produced. And once the melatonin is produced, it starts acting like an orchestra conductor. And this starts basically directing all the reactions. There are signals that are sent to all kinds of receptors in our body that are responsible for reactions that have to happen while we sleep. And so these reactions and different metabolism takes care of repairing damages to the tissues. It takes care of basically, and also helping boosting our immune system. And then of course we have important brain cleaning, the beta amyloids that accumulate in our brain, which are toxins, and then it also helps with our memory consolidation. So we have basically some body function that happen only during the day, and then body function that happen at night, and they all have to be synchronized for us to feel in optimal condition. And so that's called our circadian rhythm, where circadian means with a daily time step, and it has a 24-hour cycle. And what keeps us on this 24-hour cycle is exactly the presence of light, this alternation of darkness and light, and that stimulates the production of melatonin. If you put a person in a cave in a complete absence of this day and night regulation, then we have found out through several experiments that our clock goes a little over the 24 hours, not exactly 24 hours left by itself, but melatonin helps it reset it. And so if we don't have too much light exposure in the evening, the melatonin starts being secreted in the evening as soon as kind of the sun goes down and around about 2 hours before we go to bed. And in this graph, it's shown in the light in blue. And then it kind of peaks in the middle of the night. And so, as I mentioned, when there is melatonin, all our night functions take place. And then in the morning, towards the morning, the melatonin gets suppressed, and then eventually we wake up. At the same time, we have also circadian rhythm with our body temperature, which goes down at night and reaches a minimum in the middle of the night. And then, then in the morning, when it starts increasing again, then the melatonin gets suppressed. So basically, if you expose yourself to more light in the evening, you are shifting your body clock forward. So you delay your body clock. Instead, if you expose yourself to light in the morning, you move your clock a little earlier, and then you will feel sleepy a little bit earlier in the morning. So any changes to this are called, so if you have persistent changes to this clock, and so your body is not synchronized, you have what is called the circadian rhythm disorder. So we have evolved basically for a very long time with just natural light. I mean, humans have figured out how to start a fire, okay, 70,000 BC. But then for a long time, we had lights, for let's say oil, candles. We figured out how to make candles, then some kerosene. So pretty much like lights that have a lot of, a big portion of infrared, but mostly kind of red lights. So lights that produce a lot of heat. They produce some light, but in the evening, they're not extremely efficient at alerting us. But then things really started changing in the 1800s when we figured out electric light. And so with the introduction of light technology, we have basically revolutionized so many things. I mean, that coincided also with our industrial era. So we have modified the spectrum of the type of light we expose ourselves, the intensity. much brighter light, and the timing. So now we can have light anytime we want. Just we go from work, we're in the evening, the office, we turn on the lights, then we go in the car, maybe we go shopping in the streets, we do some window shopping, we have all the street lights on, and then we come home. First thing we do, we switch on the light. And then, so basically, we don't get exposed anymore to this crepuscle, this light subduing until much, much later in the evening. So we know that different light sources have completely different spectra. So in this graph, I'm showing you the sunlight. You see it peaks around in the green-blue at noon. So, and this is indeed exactly the light that keeps us most alert. Let's say you feeling sleepy, just go out, take a good walk, and in the morning, a good refreshing walk with a lot of light will help you kind of wake up. In the winter, it's a little harder when we have to go to work, when it's still kind of dark outside. But then our first lights were like the tungsten lamps. So they were more incandescent lights and get really hot if you touch them. So a lot of infrared radiation and also thermal infrared emission. But then we started using kind of switching to brighter lights, you know, the ones that you find in the sports arenas or in the parking lot where you have maybe a soccer field or the car. Some places are really illuminated. So certain commercial centers have this really, really bright light that even if you go there in the evening, it seems like, oh, it's still daytime. So those are maybe mercury vapor lamps, and they have kind of narrow peaks in the green and then in the violet, and then the white LEDs, really bright lights. And so they peak in the blue, and the blue is where also our intrinsically photoreceptors are intrinsic photoreceptors are most sensitive, and to stimulate them or suppress the melatonin production. So if we see a lot of blue light, the melatonin goes down. So over time, nowadays, we have basically, wherever there are humans, we have created so many outdoor light sources. Of course, we have lights inside, but even outside, so much light that it's basically almost impossible in the most populated areas, which are shown here in red. There is basically, you never experience a true night because there is always too much light at night. And once, because also the issue is that once you illuminate a place outside, you're maybe intending to just illuminate the ground, but there is a lot of reflection. Maybe the light is not shielded on the top. The street, there could be cement, it's highly reflective, it reflects back into the sky, there could be a lot of aerosol pollution, and so low clouds and lots of reflections. And so basically, the light pollution issues are huge problems, not just because we are not seeing the night sky, so it's impossible to see the stars, disturbing a lot of animals, a lot of insects, a lot of turtles, and different animals, birds chirping all night, but also our sleep. So we were really curious here to see if we could use measurements of nighttime radiance that have been collected now a little more precisely since at least the mid-90s with the Defense Meteorological Satellite Program, the Operational Linear Line Scan System. If we could use these lights to understand if there is any impact on the sleep of the population. So just to remind you, if you're not familiar with this source, it has daily acquisition, generally around between 9:30 and 7:30 in the evening to 8:30 in the evening at local time. The spatial resolution is quite coarse at 2.7 kilometers, and it has a panchromatic band that goes from the visible to the near infrared. And while the satellite data are collected daily and they were devised to aid military nighttime navigation to map clouds, it was found that if you reduce the gain setting and you took the images, just the images of the cloud-free nights during the dark phases of the moon, and then you composite them over several nights and then got rid of all the stray lights of the lightning and unstable lights, you could create some pretty good radiance nighttime light product that then has been used for several purposes, to look at the electrification rates, to look at population density distribution. It's not a perfect data set, but it is pretty good. And then the data sets were being produced from 92, but pretty much better quality since 96. And then until about 2014, I think it's the last one, or 2013. And so an annual data set that gives us a pretty good idea of the nighttime light pollution condition at different locations. So we wanted to find out in this study if there is a relationship with the intensity of these outdoor nighttime lights and the sleep of the general population. So what is the general population? The general population, this study has been published in a journal called Sleep. It's a medical journal, and in 2016. And so the general population is not population that has sleep disorders. So it wasn't selected for people, oh, these are the people that have sleep problems, let's see what kind of light they have. No, this is really all of the population representative of the United States population. This study of collecting epidemiological data on sleep of healthy and unhealthy people has been conducted by Professor Ohayon of Stanford University since many, many years. And he has the largest database representative of populations for different countries. So probably his best data set is for the United States. And here he sampled the adults, so 18 years and older, living in 15 states over several years. He has 15,863 complete interviews that were conducted between 2003 and 2011. So these are very, very in-depth interviews that are conducted using a system called SleepEval. There are hundreds of publications on SleepEval, and it's an expert system devised by Professor Ohayon that uses an inference engine that has a large knowledge base that includes the International Classification of Diseases, the International Classification of Sleep Disorder, and the Diagnostic Manual of Mental Disorders. So these are all the manuals that the doctors use to evaluate diseases in a person. So this system is part of the knowledge base, and then a non-monotonic expert system that uses basically neural network to feeds off of the answer. Also, it has some standard questions, and then depending on the answer of the interviewee, it decides which questions should be asked next, so that there is non-redundancy, and then also to evaluate that the interviewee is not contradicting himself, because sometimes the memory may be not good, or sometimes maybe he doesn't want to talk about certain aspects of his life. It's very, very thorough, but the system understands when there are some contradictions, because being non-monotonic, he kind of asks some follow-up questions and then basically digs deeper. So the interview is extremely thorough. Of course, there are some socio-demographic information, age, gender. If kids are present, kids disturb sleep a lot, so we need to know how old are the kids, and then what time you go to bed, how do you sleep? Do you sleep with the light on? You sleep with a partner? You sleep on the floor? What kind of drugs you're taking, any kind of diseases, any kind of pain and other health issues. And so measures, as I mentioned, very, very thorough. So most of these interviews are conducted over the phone, over several settings. So they're not usually, it takes a few hours to go over the whole thing on a healthy individual. So just to give you a kind of an idea of the type of questions, then also the type of job the person does, its work schedule, and how he feels during the day, and if there are any sleep attacks, and if there is noise, if the population density, what kind of bed you have. So very, very, very thorough. So we combined the SleepEval system interviews by geolocating them on the ground, and then combining them with the nighttime lights for the period closest to the date of the interview. As I mentioned, the interviews were conducted between 2001 and 2011. And so assuming also that the person just doesn't have the light in his neighborhood, but it has a certain radius. So we took a 3x3 window centered on the interview address. And so, I mean, it's not surprisingly, so what we found that, of course, population density is strongly correlated with the amount of light of a place. So indeed, you know, larger centers have more intense lights, greater radiance. But we also found out that what happened is that after adjusting for various effects of population density, age, gender, occupation, living with children, or if you have a bright bedroom, or if you sleep with the light on, and if you have noise, what was the most strongest element relating to the nighttime radiance was the sleep duration, and having an increase in nighttime radiance was associated with an increased likelihood of sleeping less than 6 hours per night. And it was strongly significant. So the brighter a place, the less most of the people slept. And the other surprising fact was that the brighter a place, the later the people went to bed. The brightest areas were most likely associated with going to bed after midnight. And this again was even accounting for population density, a bright bedroom, or noisy bedroom, and watching TV in bed were also unrelated to a later bedtime. So we're not, that was just the radiance. And so people go to bed later, but what happens, they also wake up later. The brighter the radiance, the brighter the lights in the area where the interview lived, so the wake time was later. And basically, we have less sleep, a shift in sleep, and so a sleep in going to bed, is a shift in waking up, but overall not longer sleep. So duration is shorter, people are going to bed later, but they still need to wake up in the morning because your job, your kids need to go to school, there is the light outside that wakes you up anyway. So what happens is that with increased nighttime radiance, we also found more severe excessive sleepiness during the day. So excessive sleepiness is when you feel like in the middle of the day, you say, oh, I can't go on, I can't concentrate, I need a nap. And in some people, it's a little more drastic than others. For example, some people, when they go to maybe a conference or a talk, you cannot stay awake. Maybe they dim the light and then in the middle of the day, you just want to sleep and can't stay awake when somebody's talking to you. So this is what is called excessive sleepiness. And if you are experiencing this, it's because you're not sleeping enough. And I used to experience it, and that's how I went and studied this. And now that I learned about this, I'm not experiencing it anymore. So, in conclusion, so the study showed that effectively these changes in light intensity and light spectrum, but we couldn't look at the spectrum, we just look at the light intensity alone, was associated with this widespread effect on the sleep patterns. And most likely through the suppression of early evening melatonin. And the other fact is that we also know that once you expose yourself to light, not only you have a suppression of melatonin, you not only go to bed later, but you also have less slow wave sleep, so less deep sleep. And the deep sleep is the one that really rests you more. So it's a combination, could be a combination between the going to bed late, not having enough sleep, and then also not sleeping well. So also a change in the quality of your sleep. So the data that we used were kind of imperfect, right? I mean, and now the DMSP calibrated radiance were perfect to match the time of the interviews, but they're quite coarse, they're panchromatic. So what kind of data would be better if you want to improve monitoring public health with nighttime light? So we would need, for example, a spatial resolution of maybe at least 50 meters to resolve differences in street level light fixtures, because we have different types of lights depending on where we are, in different spectra also. And of course, we would need multispectral bands. And a study done by Elvidge, Chris Elvidge, who has curated the lights data sets for many, many years, has found that a combination of the Landsat TM bands, like the RGB bands, and then a little broader near-infrared band would actually be able to distinguish most, let's say 96% of the types of lights. So it would almost be as good as having a perfect spectroradiometer. And then we also need to pay attention to the time of acquisition. Now with the VIRS lights, which have much better spatial resolution at 750 meters, still not perfect for this kind of studies, but the VIRS data, day-night band, is acquired at 1 a.m. in the morning, 1:30 in the morning. But lights tend to kind of peak around 8 to 9 p.m. And then as you go on, this is an image taken from the space station at night, they tend to go decline. So if you take the lights, let's say around, here is around midnight and here is around 2, 3 p.m., then you miss a lot of the intensity. So a lot of the night lights get turned off for various, because nowadays there are restrictions in the amount of light that you can have at night, and also for energy saving consumption purposes. And so that's another aspect that we would need to take into account. But anyway, in summary, wanted to share that basically, so be aware that the nighttime lights in the cities clearly impact our human sleep. They contribute to a shift in the bedtime. They reduce the sleep duration, and they also have they affect your daytime functioning by reducing your sleep quality and needing so probably to be less productive during the day. So is there something that you can do about it? So first of all, try to spend time outside during the middle of the day. Be also an active citizen, support the use of fully shielded lights. So not lights that illuminate the whole sky, but that kind of direct only the light down towards the ground or towards the area that needs to be illuminated. And so design appropriate outdoor and roadway lighting in your community. And also select lights with a warmer color for both your outdoor and your indoor lighting, and then dim the lights in the evening. So especially towards after dinner, put screens on your blue light screens on your devices, dim the lights in your house, just allow your melatonin to be secreted. So I hope you found this talk interesting. It's a little different from what you probably have listened so far, but now I would like to switch to the second part of my talk as anticipated, and talk a little bit about my role as managing editor, chief editor at Insider of Science and the Panda Edit Network, and talk a little bit about scientific writing. So at Insider of Science is a company that provides professional editing services. And it's unique because the manuscripts are edited by scientists for other scientists. So experts in your fields look at your papers. I submit the papers that are, there are hundreds of papers, to the right person that I know has the expertise to not only edit your English, but also give you some tips about the overall, and really understand how to rewrite your sentences when they have problems. And sometimes they're really good, they just need a minor polishing. So we work on manuscripts that are to be submitted to journals, research papers, conference abstracts, grant applications, any other kind of academic document. And this is the website It's actually it's in Chinese. Here I have it in the English version, but there is a Chinese version. And it also keeps track of job searches and other important events. So I invite you to go and take a look at it, even if you don't need to have your paper edited. So a little bit about us. So all of our editors are professors and active researchers. They perform research just like you, and they also publish their own research. And we provide and encourage also some active interaction between the editors and the authors through scheduled video meetings, over which we can go really in depth and help you address your most common kind of areas that need a little more kind of, if they are more like structure related, if they're more like grammar related, if they're kind of sentence structure, kind of really understand how to improve over time your skills. And we always explain the corrections and the main corrections that we have made. And so overall, we want you to basically improve over time. We don't want to always see the same errors repeated. So we have a number of doctors, and we also have different areas of expertise, of course, earth science, but also we go into biology and medicine, material science and chemistry, and computer science and big data. And again, in experts in the different fields. So our editors do extensive line-by-line editing. They correct the grammar, but also the style and the flow. All the manuscripts are generally reviewed by 2 editors. There is one editor, and then a senior editor goes over just to make sure that everything has been done correctly. And we also provide a little summary at the end where we kind of give the strength of the submission. For those that are a little less experienced, perhaps they need to pay attention perhaps to more of the structure, or perhaps we think that maybe the journal fit is not the best. Maybe there are some other journals that can be considered for the specific articles. Perhaps it's too technical or not technical enough for the type of submission. We provide the authors also with a slide deck where we kind of give examples. This is why your results needs work on, because maybe you are not describing the main trends of your tables. You are maybe giving too many details of the numbers, repeating. You don't generally repeat your numbers in the table, right? You leave them, that's why there is a table. You want to describe the main trends in the results. Or perhaps you kind of tend to repeat yourself. So we tell you why you can simplify a long sentence into a shorter one. And everybody's busy, so even your reviewer will be busy, and if he can have a better written text, he'll be more likely to give you a favorable review of and more maybe more constructive in your review, and tell you what to focus on, and doesn't have to worry about your English. Of course, so as I mentioned, we have active video sessions that can be scheduled with each of our editors, and they're generally an hour long. And so now I will talk a little bit about why it's important to use services where it's your editor also understands your topic, and what you should pay attention when you're writing your papers. Because we know that getting published and in research is really important to survive, right? So if you really need to write, you need to write papers, you need to write reviews, you need to write evaluations, recommendations, grants, a lot of grants, and you want to have your grants published too. And so to succeed, you don't just need to write papers, you also need to have good papers. So what can increase your chances of getting published? So of course, first of all, it's the content, right? You need to have original work that can advance a field. And so your paper either needs to be novel, or you can use new original data, or the idea also needs to make sense, right? And papers that also are sent to the right target journals are also more likely to get published, because sometimes maybe we get caught up a little bit too much into the impact factor, but the journal with the highest impact factor may not be the best for the right audience, right? Maybe there is a different journal that will yield you way more citations because you're reaching the right kind of people that will read and really need, you bridge the gap in the type of knowledge of that type of people. And these people will come back and cite you. And also, you want to make sure that your papers are free of silly mistakes, right? So don't rush too fast. Make sure that you correct everything. Did you report your results correctly? Did you use the right significant decimals? Are your figures of good quality? Does your legend have mistakes? You know, those are all little things that if the editor is pleased with, it will be more likely to pass the review. And especially you want that your ideas are also follow a logical sense, that you don't break your thought into multiple parts and then go back and then you add additional components in the wrong parts of the paper. So to get cited, you really want to be able to write a paper in a way that other scientists can understand you. So you want to really write to inform, not just to impress. You don't necessarily need to use very complicated language or make things overly complicated. If you have a lot of equations, unless the journal is extremely technical, you should try to explain why you're using that equation or what is the general approach of the equation, right? The value of that equation. And otherwise you will just be limited to a very, very small niche of audience that can understand the very advanced math. And a lot of the other people will say, well, I don't know, it's not my field, I cannot use this paper, I don't understand. So, and overall, you want to make sure that your paper is clear and precise. You want to be precise and brief. So to become a better writer, you have to acknowledge that writing is hard for everyone. It's hard even if it's your first language. Writing, putting your thoughts into written material is not something natural for the human brain, right? We are naturally, we walk, we talk, those are natural senses, we hear, we see, but writing is a different type of exercise that we have not evolved with. So we need practice. And one way to that really helps a lot of people is to be first talking about your research before you start writing about it. So preparing, of course, the figures first, and then maybe prepare a slide deck, offer to have a little seminar, or even you can be showing it to your friends. And that's when you realize when you have certain gaps in the logic flow of your thoughts. And so once you're done with that, once you have your clear thoughts, then you can start writing, and you write it all first without worrying too much. Then when you revise, you really start to thinking about your reader, because you want to make sure that your reader is engaged and not bored. And then when you are revising, you have to be not afraid to rewrite largely and to rearrange a lot of your structure. So you should never get too attached to your own words. You want to make sure that when you revise, that you remove repetitions, that you remove words that don't add anything, like things like as it is well known. You want to make your sentences as short as possible, precise, but as short as possible, and try to use shorter words rather than longer ones. Everyone has less time nowadays, right? So the shorter, perhaps the better. And try to avoid unnecessary jargon and too many acronyms. So if you're not going to use an acronym more than 4 times, I would say don't use it, because or if it is in a very established acronym, let's say MODIS, or let's see something else, VIRS, I don't know if who knows these satellites, or SMAP if you are in hydrology. Then, I mean, these are, of course, you're not going to keep writing the name of the satellite all in extents, because it's very long and people will probably be familiar with the name of the data set. But with a lot of other acronyms, try to not include them because they make reading really difficult. And try to not repeat the same words in the same sentence, and then try to be a little neutral. Don't put things like obvious, really, very, because they're a little imprecise, and in science we want to be precise. Use an active voice, which is basically subject, verb, object. So who does what to whom? That's what you want to call, because that's a little more engaging. And then also realize that you want to make sure that you have the right information in the right section. Of course, Einstein used to write his papers just writing a letter to his friends, right? So that was a long time ago. But since at least the 1920s or so, we established some conventions. So all journals expect pretty much the same structure. There are a couple of deviations, of course, maybe with Science and Nature and the Proceedings of the Academy of Science, or a few others that have methods last. But generally, there is introduction, the methods and the results, and the discussion, and maybe an optional conclusion. And it has this funny diagram, kind of looks like a little bit butterfly, that tells us that we go in the introduction from broad to specific, so a broad background, and then we narrow down into our specific research gap, aim of the study, and approach. Then in the methods and the results, we use a specific structure usually. And in the results, we don't start discussions, right? Unless we have a results and discussion section. And then in the discussion, we go from narrow. So basically we relate back to our results to what we were aiming to in the introduction. And then we slowly start to generalize, find the limitations, we generalize, and then we find the need for further research. So this is also a very important aspect that sometimes younger writers or so forget that this should be followed. And anyway, we should always follow back to the journal to which you want to submit and check what are their guides, what format do they follow and want you to follow. Because if you don't follow that format, the paper will not be accepted. So in conclusion, so what is good writing? So good writing is simple and concise. You generally avoid needless words. You don't try to repeat yourself too much, because if you say the same thing over and over, the reader thinks, what? He doesn't think I understand. I already read it. You already said it at the beginning. I don't need to be told twice. Unless it is really maybe your important result, that maybe you can repeat twice. And then you want to make sure that you follow your conventional structure. So how you get there? So first, talk about your research before you start writing it, and it will also help you overcome your writer's block and find any gaps in your logic and your flow. Make sure that you have this logical flow of the arguments, then just revise, and perhaps you write your paper, then you put it away for a week. Don't rush it too much. Put it away, work on something else, and then go back and reread it again. You may find, and then you will be able, with open eyes and an open mind, see if there are any things that need to be adjusted. And then you want to have, for sure, your manuscript polished by somebody that understands what you want to talk about, because that also really, really helps with improving any last things that need clarifications. So I thank you very much for your attention. And if you're curious, so here again, it's in the website of www.insiderofscience.com if you need any paper being polished. And now I'll open it to questions, any questions that you may have regarding the first talk or this second part. And so, and thank you again so much for your attention.
Thanks, Christina, for the amazing presentation. I think at first, Lei got a question from his friend at WeChat. So, Lei, can you tell us the question?
Okay, hi Christina. Thank you very much for a very good presentation. Especially the first part is about the use of nighttime remote sensing data to investigate the sleep behaviors and the differences. And the second part is, I think, another very important thing on effective scientific writing, because the structures and a lot of tips on the writing skills, I think, also important for most of the scientific scholars in the world. So thank you very much for your presentation. And second is, I received a question from my friend who is currently assistant professor, Dr. Xiao Huang from the University of Arkansas. So his question is about the how can we conclude the causation from correlation? So he noticed that from your slides, you mentioned about the differences of the sleeping duration and the sleeping quality. So maybe the difference is caused by the location difference. So the human behaviors and sleeping behaviors is different between urban areas and rural areas. And coincidentally, the urban areas have more night light brightness values. So as a result, it might be a little bit confusing about how to conclude that the more night light brightness in the worse the sleeping behaviors. So what is the causation among the sleeping behaviors and the nighttime brightness values? Do you mind to give a little bit more explanation about the correlation here? Thank you.
You're very welcome. So as I mentioned, so yeah, I didn't go into perhaps too much depth, but the analysis was conducted with multiple logistic regression. And so several hundred variables were entered. And so there were a lot of other aspects that were like exactly could be just the amount of light could be correlated to the amount of noise, or the amount of light could be correlated, could be indicative to the fact that you have a more stressful job. But type of jobs, type of occupation, and noise, having a bright bedroom at night were not important factors in the logistic regression. But the amount of brightness itself was the strongest element that was associated with the altered sleep behavior. So it's true, correlation does not mean causation, but the behavior that we saw was consistent with many laboratory studies. So basically, it was taking things that happen, that have been found in sleep labs, and that mechanisms that we know that affect sleep from studies that use electroencephalograms and scans of the brain, and applied, they reflect well with the general population. And we've had a lot of rural people too. So the type of occupation, the fact that if they watch TV at night, so remember this is like 2001 to 2012, not huge amount of cell phone use at that time. Still it was coming, but not so big. So it was mostly like watching TV and doing other things. And many people watch TV in bed, but they were asked, or some people were reading, some people had maybe a drink in the evening, but all these factors were not important.
Thank you very much. I think
we controlled for these factors. So
yeah, I think it's much more clear after your explanation, especially all those details. I think because of the time limit, you cannot introduce all those details in the presentation. But now I guess it's very very clear about the correlation here. Thank you so much.
Hi, Christine. One question about the scientific writing. One question is about whether for the big journal, the introduction and discussion would be more important than methods and the results. Seems for technical journal.
Yeah. Of course, putting well, I mean, of course, your results are important, right? If the results don't match the introduction, then you can write the best introduction, but if your results do not support your research question, then then of course how well you write will not allow you to get published. So your methods, as long as they are clear. So how you're writing the methods usually is the first step when you write the paper, because they really kind of help you going with the writing, because they're the easier parts, right? Just write what you have done. And you don't need to maybe write every single thing. There is always nowadays space for supplemental material, or if there is more questions from the reviewer, you can address more. But putting the study in the right context, and then both with the introduction and the discussion, I think it's helps good writers getting their papers through.
Okay, thanks, Christina. One more question is that, can you talk about the temporal resolution of the nighttime light data set?
Yes, so as I mentioned, then, so lights, nighttime lights from these kind of data sets, VIIRS and DMSP, but in this case we use the DMSP. They are collected, these data are collected daily, but the data get composited in an annual composite, because there is a lot of cloud. You can only use the observations from dark moon phase and when there are no clouds. And so it takes usually at least 6 months, several months, and plus on your the summer has the, whether you are north or south, it has to be during your winter time, otherwise the sun will still be there in later times, right? So you have to use only pixels that are sleep free of solar radiation, which can, and in the north, in the highest latitude, you can have daylight sun until about 11 p.m. sometimes, right? So also the data are not available above, I think, 60 degrees north, or there are some limits, because then there are the boreal lights always there. So so generally these data sets are available the yearly time scale, because they are yearly composites.
Sorry, can I just add a follow-up question?
Yeah.
So it seems, did you use like some proprietary DMSP or RS data set, because it's collected daily? Like, I think you also calculated the radiance.
Yeah.
Right?
So we use the radiance calibrated, the one distributed by NOAA.
Okay.
Yeah.
But the temporal resolution is still annual as.
It's annual, yeah, because they're annual composites.
Do you know if there's any like development on the finer temporal resolution for the DMSP data set? Because like we're daily or monthly, but it doesn't go back, right?
Yeah. So DMSP, I don't think they're produced anymore. The VIIRS, there are some for VIIRS, which is a higher resolution. Nowadays there are more nighttime, very high resolution, also some commercial or some high resolution nighttime sensors, but there are no composites for them, but they can go down to even 1 meter resolution. Some of them are commercial. For the VIIRS, there is some, but it's mostly, could there be some monthly composites? I have not checked back. Maybe.
Yeah, they have monthly, and they say they're going to release the daily.
Okay, the daily, yeah.
Oh, thanks.
You're very welcome.
Hi, Christina. One more question. Someone is asking that whether we can guarantee that the paper in editing or in polishing will not be got by others like that.
Excuse me, say that again.
Will not be seen by others.
Seen by others? Yeah, no. We have a confidentiality agreement, so these papers are really like very secure transmission of the paper, and we sign a contract with the editor for every single paper. So the editor guarantees the confidentiality, and often does not see the author unless it has to do a one-on-one video call in interaction. Then the author is revealed. Otherwise, most of the times, the editor doesn't. And we, how would we? We are secure. We are professionals. So we wouldn't be in business if we were divulging the papers. So it's not in our interest. We are really passionate about improving the quality of the papers. So
yeah, I think the situation is similar to the submission to the journal, because for the journals and also for the reviewers, they have the responsibility to make sure that only the reviewer can see the paper.
Exactly. So, yeah. So it's yeah, we wouldn't be in business if we weren't. So we have very strong confidentiality, and if we haven't had any breach, so we select our editors as very trustworthy people. So
okay,
we are we screen our we don't just accept any editors. Our editors are very curated editors, selected editors. We don't. It's not just like when you submit for a paper, the journal asks randomly around various authors if they are willing to work as editors, but we don't go randomly. We know our editors because we also need to know if they have the expertise in the topic of the paper. So
okay. And two more questions on Bilibili. One is that whether would you please show us again that whom are the editors, because it seems they are interested in whom are the editors.
Yeah, you can see a sample of editors on our website.
On your one of your slides is about the editors. You may show it right now.
Oh, you want me to go back? Yeah.
Okay. Yeah. And at the same time, I will ask the second question.
Just a sample of editors that we have here. So these are researchers at the Forest Service. Dr. Bista was at Oregon State University. She's now taking a break from there. Dr. Schul used to be at Boston University. Now it is at the University of Maryland. We have many more editors.
Okay. One more question is that whether you can provide some suggestions on the content in addition to the language issue.
So I mean, we provide some definitely suggestions on the structure, and if we think that there is some contradiction in the paper, we provide that feedback, or we say no, this doesn't make sense. So definitely we do that. But in general, because we are not involved in the study, we can only go so far, right? So, but we do as much as possible within our ability. Whatever we see, we help, definitely. But then, because we are not involved in the study, we cannot know everything, right? So, but we provide some suggestions. Yes, we do.
Okay. One more question is about science. Is it easier for for the researchers in the field of remote sensing to publish papers in the interdisciplinary fields for remote sensing?
It depends. It depends. The interdisciplinary, yes and no.
Yeah, last time we used to invite Dr. Michael White from Nature. He told us that for the subjects that are pure remote sensing, it's zero. It's zero in nature.
Pure remote sensing, no, you have to be interdisciplinary to go higher, because those journals have a wider audience, right? So you need to appeal to people of different fields. So you have to go beyond just a technique. You have to answer like a bigger research questions that is cross-cutting. For example, all of climate or all of ecosystems or the carbon cycle. So those big questions. So just a technique, unless the technique, I see like in biology, let's say you publish a new technique that helps you sequence the genome of the human body, like from one drop of blood, maybe that can, but that would be something like such a big change. Generally, you put it in the context of the biggest advantage of having that kind of technique, right? So you want to put it in a larger context.
Yeah, because I feel that finding the linkage between nighttime and sleep is still in the interdisciplinary field. It's not well studied before, right?
It was a unique opportunity to merge the data sets.
Okay.
And again, you have to find colleagues that are risk takers, because when you become interdisciplinary, you are taking some risks.
Okay.
Yeah.
So anyone who has questions in the Zoom, you can just open your video and voice. Okay. We usually have a few minutes for the audience in the Bay Area, because this webinar sessions originate from the Bay Area. Yeah, some of them work in the companies, and some of them work in the universities.
Okay. Yeah.
Could you please have a short introduction of CropSnap, because we find that you are the
okay.
owner.
So CropSnap is a data analytics company that serves yet another topic. So now it talks about mostly agriculture and serves the needs of providing reliable and rapid access to crop area statistics and crop damage statistics for crop that serves mostly the commodity markets, the future markets, and the agricultural insurance market. So myself, I have a background in agriculture. I started studying agriculture, then I studied biology, then I did an emphasis in ecology, macroecology, then I went to a school of forestry, and I worked at NASA for many years, more generally in the, always focusing on the human-dominated ecosystems, so and understanding how human and natural ecosystems interact. Then I moved into medicine for a few years, but then I really, from medicine, I was missing remote sensing too much. So I went back, and so now I do most of the work in Asia, particularly in South Asia, and serving damage assessment, crop area statistics, and also trying to evolve the insurance market so that it has to rely less on traditional field measurements. So a lot of the statistics in agriculture are done by calling up the local village, saying how much is this area, so there is not much use of remote sensing. Or you go in the field and you cut a portion of the field and you weigh all this biomass, but of course it's very expensive and very time consuming. And so we are developing methods for rapid assessment with machine learning and large-scale remote sensing.
Yeah, because many of the audience in Geoinsider work on the field of vegetation remote sensing. So in forestry or agriculture. So they are very interested in the potential applications of remote sensing.
Yeah, so the problem is that nowadays there are a lot of companies offering services, but a lot of the companies provide, so in countries where there is not good statistics, where there is not a good data sets of reliable statistics, then nobody knows what is true. So that's the main obstacle. So there are a lot of companies that come in and they do some simple relationships, just some regressions with yield data that are not true, that are not reliable. And so they build models that are not reliable. And so the government is completely confused and does not trust anybody. So just to say it's simple, it's hard to become operational when the market is not doesn't trust you, because there is a lot of bad apples in the market. But that's the main challenge, is so this rapid, I think there are many applications for making operational. So there are a lot of beautiful studies that work extremely well in experimental settings, where you have everything under control, where you know exactly what is grown, where you know you have very good experimental fields, very good geolocation. And then though scaling in this in the real world, the challenge is that often you don't have good internet signal, you don't have good geolocation, you don't have reliable people on the ground. And so you have many more uncertainties. And so you are finding the best decision. So your best decision then is based on physically based approaches, right? So you want to try to stay away as much as possible from statistical data that you cannot trust and build reliable approaches. And then the challenge then becomes in conveying and explaining the uncertainty to your customer. So how reliable the data are, right? And so it's a matter of educating also your customer to understanding statistical uncertainties and the different sources. So it's really, really very interesting going from perfect solutions to operational solutions, to solutions that can work and they have to be rapid and give answers with as much as good confidence as you can have, right? And especially to do another work that we have done a lot is doing like intelligent sampling. So a lot of the statistics in agricultural field have been developed based on random sampling, but that assumes that you don't have satellite data. But with the satellite data, you don't have to be random, right? Because you know where to exclude which areas, you know the year-to-year variability when you have long time periods. And so you can gather and garner all that knowledge and then be strategic in your sampling. And then again, as scientists, we think, oh, let's do the best optimal sampling where we're going to calculate the distance from the road and they put in the elevation and no, then again, it doesn't work. So you have to work with the human factor. So you have to train the people that can go on the ground, which will not all be scientists, and make them do very simple and kind of do, for example, take pictures from different angles and different panoramic, and understand what is the way that you can minimize error so that you can get the most amount of information from the field without having to go on the field. Because when you are surveying large areas, hectares and hectares and hectares, millions of hectares, then you cannot just go everywhere. So you have to be strategic with your resources. You have time constraints, economic constraints, because you have to stay within a certain cost of the study, and then human factor constraints. So those are the really interesting challenges that we are solving operationally.
Okay, Christina, for the last question, one question from everybody is that how to is about the language editing. How to guarantee the language editors are researchers or scientists, not the people whose major is English, but not.
Oh yeah, again, I mean, you have to trust us, right? We guarantee you will see by the quality. The quality, our comments will teach you that, will show you that we understand what you're talking about. So,
okay.
Yes.
Okay. Yeah,
because yeah, our editors they have their jobs. They are researchers, so you understand from the quality of the edits that they understand what you're talking about.
Yeah, I know. Yeah, because I find that the platform was established in 2018, originally developed by Professor Ranga Maineni.
Maineni, yes, Ranga, yeah, Dr. Ranga, Dr. Maineni. Yes.
In our field.
He's our intellectual advisor.
Yeah, our golden standard of the error index.
Yeah, yeah, exactly. Plus an excellent writer with a big publication record.
Yeah. So yeah, the editors are all of the editors are the scientists or researchers. Okay. Yeah. Okay. So thanks, Christina. Now I think time is up, and yeah, thank you very much to attend the Geoinsider webinar series.
Thank you very much, and thank you for everybody for your attention, and good luck on all of your work.
Okay. Thank you.
Thank you so much.
Thank you. Bye bye.
Bye bye. OK。好的，那第36期Geoinsider湾区遥感在线茶话会就是到这个地方就结束了。我们在下一个星期，然后会有同样的这个 webinar， 然后下一星期的主讲人是来自 MIT Sustainable City Lab 的李小江博士。他之前在 MIT Sustainable City Lab， 现在已经去做 Assistant Professor 去了。他会给我们带来关于 GIS 比较前沿的一些介绍。好的，那今天我们就到这个地方，那就麻烦刘诗涵同学把